Have you ever wanted to be able to speak a computer language? That sounds pretty difficult. You probably have to be pretty smart to speak a computer language, right? Well, what if I told you it's very simple, and it's simply the process of converting between decimal and binary numbers. I'm going to show you how to convert between decimal and binary numbers by simply using your powers of 2. This is all it's going to take for us to be able to speak a computer language. First, let's start off with, what is a binary number? We all know what decimal numbers are: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just like basic counting numbers. But binary numbers, well, according to computerhelp.com, a computer help website, binary is a base 2 numbering system invented by Gottfried Leibniz that's made up of 2 numbers, 0 and 1. It is the basis for binary code, which is the language computers read. You can see here we have a binary number, 10110001. This is indeed the number 89, but in binary form. Why the zeros and ones everywhere? Well, according to allocation.com, a STEM-related publisher, in binary we count 0, 1, and then we run out of numbers. So we have to add a numbers place, and we go to 1, 0. So 2 in binary is simply 1, 0. This is like how when we get to the number 9, we don't have a single number to represent 10, so we have to go 1, 0. So how are we going to be able to find the values from these ones and zeros? Well, according to electronicstutorial.com, binary to decimal conversion of numbers uses weighted columns to identify the order of digits to determine the final values of the number. And in this case, these values are powers of 2. So using our knowledge of powers and 2 and just using the table and ones and zeros, we're going to be able to convert between binary and decimal. But first, let's start what we need to succeed. And most importantly, your powers of 2. You have to either have them memorized or just have to have a table with you. You need a paper and pencil or something to write with, and the ability to follow simple instructions. Let's get into those simple instructions. Let's convert between 157 to binary. So as I keep saying, we need our powers of 2. So we're going to start by writing out our powers of 2. 1, 2, 4, 8, 16, 32, 64, 128, 256. You write out as many powers of 2 until you get to a number that is greater than the one you're trying to convert. 256 is greater than 157. So now we find the largest number that fits into 157. In this case, it's 128. We write a 1 above it. Then we take 157 and subtract 128. This leaves you with 29. Can 64 go into 29? No. We write a 0. Can 32 go into 29? No. We write a 0. Can 16? Yes. Subtract 16, write a 1, and then you get 13. 8 goes into 13. 13 minus 8 is 5. 4 goes into 5. That leaves you with 1. So 2 does not go into 1. 1 does go into 1. So then you write out your numbers. So that is 157 in binary by simply using our powers of 2 and subtracting the largest value that we can from our total, and then taking our new total and doing the same thing. So we continually subtract and add ones when we subtract that value. And using these powers of 2, it's very easy to visually see that our final answer is 100111101. So that's decimal to binary. Let's do binary to decimal. So we're going to convert this number 1101011 into decimal numbers. So powers of 2: 1, 2, 4, 8, 16, 32, and 64. If there's a 1 above the number, we're going to add it together. It's very simple. 64 plus 32. There's not a 1 above 16, so we don't include it. 8, not 1 above the 4, 2, and 1. So if we add all these numbers, together, we're going to get 8, 9, 10, 11, 12, 13, 7, 1, 107. So that is indeed the representation of 107 in binary. So once again, we're just using those powers of 2 and simply writing it out. We're able to add these values with 1s above them to get our final decimal number. So those are some two examples that I hope have shown you how to do the process, but we need to remember not to make silly mistakes. We have to be careful to subtract when going from binary to decimal and to add when going from decimal to binary. Do not divide or multiply at all in this process. Remember, zeros are important, just like they are in our language. They represent a gap in values, so don't sleep on the zeros. The first power of 2 is 1. I cannot emphasize this one enough. So many people forget that the first power of 2 is 1, because 2 to the 0 power is 1. So you must either have your powers of 2 memorized or have a chart with you. If you follow these simple steps and follow my tutorial I just showed you, you're easily going to be able to learn how to convert between decimal and binary and be well on your way to speaking a computer language.